have, if we're supposed to prove this identity, see how there's a negative sign next to x, it's asking us to practice using the odd and even properties of the trig functions. So what that means, if something's odd, like here, I'll give an example. Sine is odd because if you multiply the domain variable by -1, meaning if you put a negative sign in there, you get negative sine of x. It's the same thing. They both equal each other. And then let's see, tangent is also odd. Okay, plug a negative sign in for x, and it's the same thing as negative tangent regular x. Okay, you could plug in some numbers in a calculator to check. You could plug in tangent of negative 30 degrees, and you should see that's the same thing as tangent 30 degrees, just with the negative sign attached to it. And so likewise, that means the reciprocal functions, because they're just 1 over sine, right? So the reciprocal function for sine is cosecant. So cosecant is also odd. Run out of room there. And then we get cotangent, same thing. Okay. I'm just going to write cotangent. That's under the odd. Now, the two that are even are cosine and its reciprocal function. Because something's even if you can plug in a negative sign, and it's the same thing as plugging in the regular domain variable. Okay, the argument. Cosine of negative x equals cosine of x. So secant is also even. Okay. All right, so now that we get those out of the way, let's apply that right off the bat here. We've got cosecant of negative x. So I'm going to rewrite that when I copy it over here as negative cosecant of x. Okay, I use this part, the fact that it's odd. Cosecant of negative x is negative cosecant x. And so now let's take care of that secant at negative x. We just said secant is even, so that means secant of negative x is secant x. Okay, because it does this even thing where if you were to plug a negative sign in, it's the same thing as plugging in, cosine x without the negative sign. And then cosine of negative x, we said that's equal to cosine of x. And then we got sine of negative x, that's negative sine of x. Okay, and so now it's just going to be the steps of a regular proof. We want to keep manipulating this until it equals. Oh, actually, here, let's type in what we've got so far. Where's my symbols? There they are. Okay, so we applied. Here, what rules do we have? Hopefully, it lets us do all these all at once. I did all the odd-even properties all in one step. So we wrote this as negative cosecant x over secant x plus the fraction cosine x over negative sine x. So the rule we had was the odd and even properties. Let's validate that. Okay, apparently it's okay with. Excuse me. So let's see what else. What rules do we have that they want to see algebra reciprocal? Okay, the next thing I was thinking of doing is when I do a proof, I always try to put things in terms of sine and cosine if I'm stuck. Okay, because sometimes that can unlock what we're supposed to do next. Yeah, let me cut these out. Well, I don't want to lose those. Okay, this is where we're at with the proof. And so secant is just 1 over cosine, right? So if you have something over 1 over cosine, it's like the cosine is flipping up top because you'd flip and multiply the fraction. So I rewrote this using the reciprocal property, or the reciprocal definition. Secant x is 1 over cosine x. So that flips it to the top for the fraction. And then likewise, cosecant is 1 over sine. So cosecant's going to flip to the bottom of this fraction. That's going to be, and we can keep the negative sign up top, or you can take it down bottom with you. Either way, it'll still be a negative number. Cosecant goes on bottom, it becomes sine of x. And then let's just stick the negative sign up top. I don't think Alex has a problem with that. Remember, it doesn't matter if the negative sign's on bottom or on top, because 2 over negative 3, that's the same thing as negative 3 over, that's the same thing as negative 2 over 3. You punch it in either way in the calculator, it's still a negative number. So we got negative cosine x over sine x. Let's validate that to make sure we're not breaking any rules for Alex. We did negative cosine x over sine x, and we did that by using the reciprocal, the definition of the reciprocal functions. Oops, not cosecant, negative cosine x over sine x. That's a reciprocal. Okay, and now we have common denominators. So we changed everything in terms of sine and cosine. Now we got common denominators, so you can add the numerators. Negative cosine x plus negative cosine x is negative 2 cosine x over sine x. And you can see that we're almost there. So we did that through algebra. We just added two fractions with common denominators. And then the final step here is cosine over sine. That's cotangent. Okay, that's the definition of cotangent. Tangent, sine over cosine. Cosine over sine is cotangent. And so that is using the quotient property that Newton says. Okay.